Hi everyone, thank you for attending the webinar today. Just letting people join. Okay. All right, so we're 2 minutes past the hour, so we'll make a start. So I'm pretty excited for this webinar today, given the range of expertise that we've got for you, both for the research presentation and for our panel at the end. So we are very happy to receive questions from you at any point on the Q&A. So my name's Jackie, I'm the Communications Manager at iMove CRC. And this is the latest in our series of webinars looking at outcomes from our research projects, in this case on the environmental impacts of connected and automated vehicles, as you can see on the screen there. I'm also extremely pleased to let you know that we have our iMove Director and Director of Safer Roads at the Department of Transport and Main Roads in Queensland, Dr. Miranda Blogg, who's going to moderate this webinar today and will bring her own experience to those discussions at the end as well. So thank you, Miranda, for joining us and help moderating this session. And I'd love to hand over to you and take it away.
Thanks, Jackie, and hi, everyone. I'd like to start by acknowledging the traditional owners of the lands where we meet today, which are varied, considering we have folks from all over Australia. And I would also like to pay my respects to the elders, both past and present, and extend that respect to any Aboriginal and Torres Strait people here today. Let me start by also introducing our speakers. We have the technical topic first, followed by the panel. We have Darren Atkinson, who will be introducing the topic. He's the Director of Connected and Automated Vehicle Policy and Partnerships at the Department of Infrastructure, Transport, Regional Development, Communications, Sports and the Arts. Speaking on the technical topic, we have Professor Jago Dodson and Dr. Liam Davies from RMIT Centre of Urban Research. In addition, we have our panellists who are hovering in the background. Ralia David, who's the Executive Director for the Centre for Connected and Automated Transport. Dr. Megan Sharkey, who's the Senior Manager for Future Mobility Testing and Assurance at Transport for New South Wales. And Ada Lin, who's the Head of Cooperative and Automated Vehicles at Toyota Motor Corporation in Australia. Welcome, and I'll hand the speaking over to Darren. Take it away.
Thanks, Miranda, and hi, everyone. Thanks for joining us today. I was just going to give a little bit of context into the research, but I don't want to stand in the way of our very interesting researchers who are about to present. I just want to say a couple of things. From our perspective, in recent years, there've been a lot of claims about the benefits of connected and automated vehicles. Some of these claims, such as the improvement to safety and reduction in road-related deaths, are currently being put to the test around the world in real-world application and multiple trials. And so data from these activities will be required to ensure that the vehicle will satisfy safety requirements for regulatory frameworks. This material is also likely to help improve broader community acceptance of what we call CAVs, which, according to some surveys, continues to decline with some cohorts. However, other claims about CAV benefits around social impacts tend not to have had as much evidence put behind them. These include improved accessibility, impacts on the workforce, such as job losses, and environmental benefits, which brings us to this research project on the environmental impacts of CAVs. Anecdotally, we were hearing that this may not be such a straightforward positive story. CAVs could have varying environmental outcomes. For example, CAVs used in public transport could bring wide benefits. However, private ownership models, particularly when you get things like empty running, which is vehicles going back and forth to base and parking without any people on board, may well increase urban traffic congestion and worsen outcomes from an environmental perspective. So this report was developed to provide an evidence base to inform policy decisions and responses regarding the environmental impacts. For example, are there areas where efforts should be made to mitigate the worst impacts while encouraging positive outcomes? There were other issues that needed unpacking too, such as how to separate the environmental impacts of electrification through EV uptake from the additionality brought by automation. Similarly, had anyone looked at the environmental benefits of vehicle connectivity separate to those from automation? Or are we just lumping it all together under CAVs? So this work was commissioned to form part of the evidence base around the social impacts, which is crucial for community acceptance of the technology. To come back to my earlier point before I close, surveys have demonstrated that public acceptance and support for CAVs is low, which can limit their uptake and the potential benefits of the technology. However, some recent research has found that community acceptance increases when people better understand the technology and its benefits. By developing an evidence base around the social impacts, including environmental, we will have a more solid base to improve community understanding and hopefully acceptance of CAVs. So now I'll hand over to the research team from RMIT to present their findings. Please welcome Professor Jago Dodson and Dr. Liam Davies from the RMIT Centre for Urban Research.
Well, thank you very much, Darren, and also thank you to Jackie and iMove CRC for your joint support of this research. And thank you to Miranda for the introduction to this session. Liam and I are here in Melbourne on Woiwurrung land, so we acknowledge Woiwurrung people as the traditional owners. So Darren's already introduced the background to this project and the rationale for why it's an important question and topic for the policy sphere to be investigating as technology advances and our transport and urban systems change and evolve and develop. So this project was undertaken by myself, sort of lead researcher and managing the project, also with Liam, who's here today, Terry Lee, Nirajan Shuakoti, Peter Stasinopoulos, Marty Jalili, and Sayad Mojib Zareh. Myself, Terry, and Liam are all based in the Centre for Urban Research. We're largely transport and land use planning experts, and our colleagues on the other side of the project are from the RMIT School of Engineering, have a lot of expertise in the engineering, environmental performance and so forth around vehicle technologies. So this was a bit of a multidisciplinary project across not just the transport and vehicle experts, but across those of us who have urban expertise. So I'll just move to the next slide. Obviously, this was done in collaboration with the department and iMove. This work we're presenting today is part of the second stage of the project. There were two stages to the project. The first was a literature review on the economic, environmental performance and impacts of connected and autonomous vehicles. That was completed in mid-2024. This presentation today is based on the stage 2 part of the project, which was the policy scenario analysis on the environmental impacts of CAVs. That was completed early in 2025. All those reports are available via the iMove CRC website. I didn't quite have time to get a QR code set up, so you could go directly to those. But if you go to the iMove website, you should be able to find those reports without too much difficulty. So just before I hand over to Liam, a little bit of background on the approach and methodology. As I mentioned, the stage 1 part of the project was a literature review, looking at the likely or potential uptake levels and rate of uptake of CAVs, and then looking at the environmental performance of CAVs across the vehicle, so the individual vehicle and the technology embedded within it, the fuel systems, and the autonomous component of the technology and the environmental impacts of those elements. The transport system in terms of VKT, congestion, so forth, the typical transport performance questions and issues, and then the urban systems in terms of potential impacts on land use distribution, on urban structure, urban form, and so on. And then the stage 2 report was on the assessment of the policy scenarios, looking at linking the factors from the literature review to possible regulatory and policy responses and tools. That also included a survey of policy and subject matter experts. So we took the insights we gained from the literature review and went out and surveyed people in the field, though noting that this is still a fairly specialist domain. But we got some really great survey responses from people who work in this area and doing a lot of thinking and analysis of the future uptake of CAVs, who informed through the survey. And then we used both the literature review, the expertise of the team, particularly those in the urban research space, plus the survey responses to develop policy scenarios and to do more analytical and policy focused work to look at different rollout scenarios and their implications, and not just what is the technology, but what are the institutional settings that sit around CAVs. So, for example, would they be taxi fleets or would they be personally owned vehicles? Because the implications for use, the technology is probably fairly similar, but the implications for use cases is quite different depending on the institutional setting. So that needs to be part of the policy scenario analysis. What kind of arrangements will we have in place for the uptake, the management, the governance of CAVs in the future, and how they then have implications for the different degrees or extent of environmental impacts, but also the nature of those impacts, and also the impacts on the transport system as well. So I'll now hand over to Liam. I'll be still commanding the slideshow, but Liam will be talking to the slides, so hopefully we can coordinate ourselves and invite Liam to speak now.
Thanks for the introduction to the project, Jago. If we go to this slide, shows the 16 factors that were identified in the literature review. We've categorized these into the 3 levels of vehicle level, which relates to the CAVs themselves. These factors are eco-driving, which could decrease energy use by around 15% according to the literature, but that would also allow for faster maximum driving speeds. The reason that could occur is that when they're connected and they're talking to each other, the space between them can decrease. They can move faster because they know what's ahead of the road because it's other CAVs. These 2 factors are both linked to each other, but they're also linked to an uptake. You need a critical mass of vehicles on the road to be able to unlock some of these. And you'll see that in the right-hand column of this table, there's a number of factors that are all contingent on uptake. 2 of the vehicle level factors are contingent on uptake. The 3rd vehicle level environmental impact is the materials in the vehicles themselves and the connective networks. So when we talk about connected autonomous vehicles, they're different to electric vehicles and self-driving vehicles in that they also have an infrastructure that allows them to be connected together. This includes roadside telecommunications equipment, data centers, communications networks, etc., etc. These have land space impacts in that they take up land. They also have energy impacts in that they require energy. Now that could be renewable, but it still requires the production of energy capacity. But they also have the materials themselves of these data centers, which means that if we look at a connected autonomous vehicle fleet and its required infrastructure, it can have higher material inputs than either standard internal combustion engine vehicles or electric vehicles. Another thing just to note here is that we assume that all of these are electric rather than internal combustion engine, and the comparison that we're trying to make where possible is against electric vehicles to give a like-for-like comparison of what the future could come out with. We can then move to a transportation system or a transport system. We have a series of variables here that are around the way the vehicles are connected to each other, such as route selection optimization and platooning and traffic harmonization. Both of these can decrease the amount of energy required by reducing travel, time and impact, but they're again reliant on a heavy uptake of vehicles. You need a lot of them before they can start platooning together, which is that type of eco-driving that I was saying at the start. So they can be interlinked. Sometimes the vehicle level and the transport system level can have an interplay with each other. The other factors that we see at the transportation system look at the broader implications of it. So we can see that we have some, and I should just say here, just that I haven't mentioned it, but it should be obvious, but the cells that are shaded in green have a positive environmental impact, and the cells that are shaded in red have a potential negative environmental impact. And we can see that there's a potentially mixed outcome here at the transport level. Shared vehicles and CAVs that complement public transport could lead to a decrease in environmental impacts by reducing the amount of vehicle kilometres travelled. This could mean we need less roads in our cities, which will be spoken about next, but it means that less travel occurs, less vehicles, less environmental impacts from vehicles. On the other hand, if it's a very individually used system, and CAVs can offer easier and more attractive travel to a vaster group of people. For example, currently, people that are going out for a drink, they can't drive a car. Well, at least they can't drive legally and they won't drive often. But a autonomous vehicle would allow people that currently can't drive, like drunk people, to be able to drive. Therefore, you can see how this logically starts to increase the amount of kilometres travelled on our road. It also increases the attractiveness, that if you don't have to park or you don't have to worry about driving, you can basically treat a car as the extension of your lounge room and travel around in your lounge room. In a way, we see this on public transport already, that people will stare out the window, daydream, play on their phone, listen to podcasts, things that you can't do so readily when you're driving a car. So this shows there are two different options we could get to from a transport system. When we move to the urban system, we can look at the communications infrastructure, which I was talking about earlier as part of the material input. We can also look at the role that EVs could play on the existing urban environment, but also how the urban environment could change over time. On one hand, we could have decreasing parking requirements, which means that we can have infill and compact cities. But on the other hand, we could have spilled overflow of parking effect into other areas, which may require more parking, especially if empty running isn't permitted, which means that the vehicles can't drive without someone. Therefore, we'd need parking elsewhere. We could also see an increase in urban sprawl if we get easier, more attractive and freer flowing traffic and it moves faster, people could move further out. We already see that automobiles led to urban sprawl. Connected autonomous vehicles could lead to a second wave of urban sprawl, which could make our cities even larger, which of course could impact our travel patterns. And if we move to the next slide, please, Jago. What we've tried to do with these categories of factors is try to link them to potential regulatory and policy tools. Here we have the regulatory tool on the left-hand side of this table and a permitted required or a permissive system in the middle and a highly regulated system on the other side. And green indicates a positive environmental impact and red indicates a negative impact. So it's about whether we allow these things or not. So the first thing we can talk about is allowing permissible technology such as eco-driving. If we allow that, it allows other things like route selection optimization and environmentally beneficial. If we forbid it, it will lead to more environmental impact. So obviously in this one, it's clear cut that it's environmentally beneficial to have eco-driving. But platooning has one each side. If you have it, it may make easier and more attractive travel, which has an environmental disbenefit. If you disallow it, it goes the other way. So we can see that in this matrix, we've tried to link policy settings that are available to governments with what the urban outcomes and environmental outcomes could be. And the reason we've done this is so that we can try and feed into a policy analysis with a replicable, robust set of inputs. And the next slide shows our 6 scenarios. These are arranged on a spectrum. The bottom shows a left to right of low to high level of regulation and collective use. Those at the low end are less regulated on their use and overwhelmingly more privately owned. On the right, they're heavily regulated or highly regulated, we've said, towards collective use where possible with limited individual use. And in the middle is a balance between the two. Then we can also have a vertical axis, which shows the level of EV uptake under each of these scenarios. So low being a lower uptake of vehicles of less than half the fleet, and high being high of over half the fleet. This is important because it shows it can allow us to interrogate those unlocked potentials through an economy of scale that you get from the vehicle fleet. If we scroll to the next slide, we can see the different policy settings that we have shown for each of these. Now, this one takes a little bit to digest, so I'll try to go through it a bit slower than I have been. But each column is a different scenario, ranging from deregulated to a high uptake on the left to highly regulated with a low uptake on the right. And then we have 4 settings of regulation related to vehicle production. In all of them, we've suggested that eco-driving would be permitted. That is a reasonably simple one that we would want to allow for. They also all allow for platooning. But it's in the next 2 that you can see that we've got a little bit of difference. So to try to mitigate some of the environmental impacts from these vehicles, the scenarios 3 through 6 have regulated design to try to minimize vehicle material inputs and try to regulate recycling, reprocessing to try to encourage a circular economy for this through stewardship. Similarly, on the design of regulation and communications infrastructure has the same factor. So this shows that the highly deregulated scenarios, basically you could build whatever type of vehicle you want as long as it fits within current standards, and same with the data centers behind them. On the other scenarios, these have to meet better environmental performance standards, including suggesting the data centers have to be low impact on water, renewable energy, low noise, etc., etc. Below this, we then have 5 policy settings related to the vehicle and road systems use. Private use of connected and autonomous vehicles or automated vehicles is permitted under the first 4 scenarios. So the deregulated and the semi-regulated or the lightly regulated versions in the middle. However, in scenarios 5 and 6, we have controlled private use. This isn't saying that no one would be able to use them, but they would have some level of control and regulation around them. And we'll get to this in a second. Because that allows for a greater direction of these vehicles towards shared, connected or autonomous vehicles. We don't see any reason to disallow shared use of connected and autonomous vehicles. The settings that we would be concerned around that are empty running and empty occupancy, and that is a separate question to whether they could be used by mobility as a service companies such as ride-hailing services. The next level, though, down is whether connected and automated vehicles complement public transport. And this is to say there would be no competition permitted. This would mean that if you book a shared connected vehicle and you wanted to go on a route that a public transport service of comparable quality in terms of time was going on, the booking simply would not go through. You would have to then transfer to a station. That's under scenario 5 and 6. So all CAV under this scenario would have to complement public transport services. Under scenarios 3 and 4, shared CAV would have to complement public transport, but private use would be allowed and unregulated, and you'd be able to use that. Under scenarios 1 and 2, everything would be able to compete with public transport. We're seeing this as a model that many of the ride-hailing companies have been going after. They know that it's actually not vehicle ownership that is the greatest attractor for trips. It's public transport systems. They've been openly trying to cannibalize these systems without naming any names. It's clear this is why some of them are operating in CAVs in the cities they are. They're going after public transport. The next level down is around operation without an occupant, i.e. empty running. Scenarios 1 and 2 are totally deregulated in this. They allow that. The other 4 scenarios of scenarios 3 through 6 are much more regulated in this, and they do not allow empty running, only under limited circumstances, which means that therefore the CAV becomes much more of a replacement of the car. This is important because empty running unlocks, it removes a constraint that we have in our urban policy toolkit, which is how much parking do we have at the destination. Empty running means that you can run as many vehicles as can fit down the streets, whereas if you can't empty run, you can only run as many vehicles as you can fit in the car parking lots. This is one of the great containment strategies that urban centres have, especially Melbourne and Sydney CBDs as 2 examples. They're very high public transport mode share because driving is not an option for many people because they can't park. And the last one is the raised speed limits that would be allowed in scenario 1 and 2 in all circumstances, but regulated in the other 4 scenarios. Now, if we move to the next slide, this shows an overview of those policy settings that we just looked at with environmental impacts. Now, the green shading indicates a positive environmental impact, and the red indicates a negative policy impact. We've also included in this a ranking from the expert survey groups on the environmental impacts of these different factors. And H denotes they agree with the impact of the policy. M denotes, and M is a medium. I think it's high and medium. Sorry, that is slightly ambiguously worded there. What we can see from this is that scenario 1 and 2 overwhelmingly have negative impacts, whereas scenario 5 and 6 overwhelmingly have positive impacts, and 3 and 4 of the mixed regulation approach have a more diverse set of positive and negative impacts onto the transport system. It must be noted here, though, that not all of these impacts are equal. So some of these impacts may be a larger scale of impact on the environment. For example, may I just say, raised speed limits may not have as negative an impact on the environment as competing with public transport. But this is just to say the general trend of direction we go into. Now, if we go to the next slide, we have some of our key findings and discussion. These are the outcomes of our policy analysis, which is many of the environmental impacts will not be seen while CAVs are at a low penetration level. With an uptake below 50%, there are not thought to be significant impacts. It's only as the fleet becomes larger that we start to get both the potential to have maximized benefits, but also see and realize the externalities and negative externalities, particularly of these connected and autonomous vehicles. This to us reveals that there is a need for government policies to be forward thinking about what types of transport in urban future is desired and implement policy settings to support the realization of that future. We're at a crossroads point here when the technology is still young and nascent before it's rolled out to be able to set the pathway that we go on through good regulatory design. Most of the expert survey group respondents also believe there will be a low penetration of CAVs in the motor vehicle by the year 2050, up to 40%, noting connected vehicles are expected, or more electric vehicles before the CAVs. This means that CAV impacts may even be unlikely in the time span that we were looking at of 2050, but maybe in the latter half of this century. Really what that means is that we may have more time to regulate this, but it doesn't remove the need to have positive regulation. And proactive regulation and policy which supports this future vision is critical in the adoption of CAVs in a manner that ensures environmental benefits are maximised. And as I said, the negative externalities are minimised. We feel that policy and regulatory tools present the best opportunity to maximise positive benefits of CAVs and minimise negative effects, and that policymakers should be strongly considering environmental impacts when developing CAV policies. And we really do talk about this in a very broad sense of environmental impacts. The scope of this work was not limited to tailpipe emissions or even energy input. It's really the broader issues. When we were speaking with the department at the start, they were very clear. They were much less concerned about those factors in this research because they're taken as a granted that the energy systems can be cleaned up. It's the broader environmental impacts of our air quality through tight particulate matter and braking matter and the land use that we're much more concerned about, and the resource use that we're much more concerned about. So we really do therefore emphasize that we need a good regulation system, and that allowing highly deregulated production and use of CAVs has the potential, if and when met with high uptake, to increase not only the energy use of motor vehicles beyond what EVs would take, well beyond it, but also the number of trips and vehicle kilometres travelled. This would act to undermine public and active transport, increase congestion. It could potentially increase the need for more roads, undoing any of the benefits through platooning that the connected vehicles could create, and become much environmentally worse than if we didn't have them at all. At a vehicle level, we suggest that the greatest positive environmental impacts can be seen in scenarios which permit eco-driving, limit speed, and place design regulations or policies on vehicle manufacturers. There's space to regulate at the start now, rather than trying to regulate after they've been produced and after they're already on the roads. So again, to be proactive about vehicle regulation. At both the transport and urban system level, the greatest positive impacts can be seen in scenarios which ensure CAVs operate in a way that complements rather than competes with public transport while limiting urban use. Again, this is an area for regulation and policy design that encourages these vehicles to be used in ways that maximize positive environmental externalities. And at the system level, the greatest potential for negative impacts is associated with ubiquitous and unregulated use. And can we go to the next slide, please? It's also clear to suggest that there's a lot of uncertainty here. The impact of some CAV factors remained very unclear based on the expert surveys, and this uncertainty can moderate the environmental outcome of any policy scenarios. The expert survey group ratings on CAVs can support further review of the identified policies and reveal more targeted solutions to maximize benefits and avoid negative impacts of CAVs. Essentially, we need more research. I know that's very easy and it's very typical for a researcher to go, we need more research. But this is asked, while the research question was what are the environmental impacts, what we've revealed is there is potential for quite significant environmental impacts in both negative and positive directions. But there are a lot of research questions that remain unanswered as to what the level of those impacts may be in more specific detail. And this really links to that insufficient research has been undertaken to date to disaggregate the environmental impacts from CAVs and emissions offered through the uptake of EVs. It was really difficult to disentangle from the literature where are the environmental benefits and disbenefits from CAVs as separate to EVs. And this was a real challenge, which again leads to more research. And similarly, there's been insufficient research to disaggregate the environmental impacts of CAVs with other vehicles with a high level of connectivity. And anecdotally, it's believed to be the combination of automation and connectivity which will provide the greatest economic benefits, but again has the potential for the greatest economic negatives. This concludes my section of the key findings and discussions and of presentation of the policy.
Thanks, Liam and team. Very interesting presentation. I think we can move to the panel session. So cameras on panel, because I have a lot of questions. We also have some questions from the audience that were received a few days ago. I'll start by targeting some folks, but you're welcome to jump in and I'll check in. I thought I might start with Liam and Jago. In terms of being proactive, is there anywhere around the world where we can see examples of this already happening?
I can see we both have.
Matt,
Go on,
maybe I'll
Jago.
jump in on that one.
Yep.
Look, it wasn't part of our analysis to go and specifically start to do some comparative assessment of what regulations have been brought in. We were really looking at the sort of an earlier stage of the issues and problems of background based on the technologies, not doing comparative work. Anecdotally, though, I would say part of the challenge, well, there's two major parts of the world where these technologies are being taken up. One is in the US, which is relatively deregulated, although in the case of, say, California, there is Department of Transport oversight and of the rollout of the technologies at the street level, and most of that is through sort of autonomous taxi cab type models. In part, there's also a big data collection program associated with that, especially around safety and to some extent around environmental performance. The other area where we are seeing autonomous vehicles in a taxi cab model being adopted is in China. And I must admit, I don't have quite as much access to the material in China as we do have through the sources in the US. One would imagine, given the extent of state regulation of all aspects of the transport system in China, that they would have fairly robust frameworks to manage and govern the rollout, and indeed probably a strong likelihood that some of the companies that are rolling out those vehicles are actually state companies as much as private companies. So that's a bit of a very sort of initial observation on that front, but maybe Liam would like to share some of his thoughts as well.
I was going to say the same thing. It wasn't really within the scope of works to look at. The research was also undertaken about 18 months ago, which may not sound like long, but in this policy landscape, it's actually an eon ago, and we've seen far more operation of connected and autonomous vehicles, or at least autonomous vehicles that can give us an insight to this, particularly in California. I would mention, though, that we can actually look back to other forms of transport disruption to see what's happened. So in the 1920s, we saw in Victoria a nascent taxi cab industry that started up that was doing exactly what we see now. They were competing with public transport. They were stopping at tram stops just after a tram, or in bus stops just after a tram or a bus had departed, and charging the passengers that had just missed the service an exorbitant fee to catch them up so they could catch the tram because they were running late. That led to our first forms of regulation of the cabaret industry back in the 1920s and 30s. We also know what's happened with ride sourcing services that have gone in and basically gone for a deregulated, break the rules approach. And I think that we could all agree that if we had have gone in and been more proactive with regulation and enforcement of these services when they were starting, we'd probably have better urban outcomes now. And much of the advantage of those disruptions that were promoted at the time of better quality services have been deteriorating over time as they seek to profit maximize rather than capture market share. Those are my cynical views.
Thank you, Liam. It is interesting that we've got a lot of attention domestically and around the world on the legislation to make safe, and what models may best suit those emerging that emerging legislation. Does anyone else have any thoughts on, more the policy front, the proactive policy in terms of this urban and energy setting, that federal and state governments may be looking at around the world? Have you seen any other practicing models, emerging models?
I'll go, Miranda. I'm curious, and I enjoyed reading it, thanks, Liam, about the urban planning and the shifts if we look at 2040 and 2050. So I'll use Paris as an example. They have tackled the decrease in personal car use through revolutionizing cycling and micromobility, and they've achieved a stepwise change in a very short time. So can those things occur in enough cities before CAV penetration so that the differences in urban planning actually create a different urban model? We're seeing that in Sydney, like the Greenway is just going through the roof. So I think that there's actually already shifts there where the urban planning mistakes of car use, we're already trying to change them. And it's whether or not we can push that further before the CAV levels become too ubiquitous. And I think, that then leads to costs and all those other bits, but I'll leave it there. Thanks.
Thank you. Okay. If no one else has any comment, I'll jump to Darren. Darren, there's some good suggestions in here about deregulation and potential policy regulation or more highly regulated environment. Where do you think federal government or what's next, I guess, from a federal perspective in terms of the outcomes or observations from this particular piece of work, noting that many of the highly regulated elements would be federally led, certainly wouldn't make any sense from a state-by-state perspective.
Yeah, look, we think the report is a really good first start to building that evidence base that we talked about at the beginning of the process here. It's a very wide-reaching report. It takes a very holistic approach, and I think that's the way to do this. Transport systems do not exist within by themselves. They are linked to the broader environment, to land and transport. To planning issues, to environmental factors. Now, I think that, as I said, that it's a great introductory piece of work for teasing out the nuances of what was initially just a very simple story about, oh, well, cabs were great, they'll be good for the environment. And what we've seen from the report is that's actually a much more complex set of issues to consider now. So this is where we start to think about policy responses. You would be a brave person to try and outlaw personal cab use in a free market democratic society. So that's probably not on the cards. But how do we incentivize and have those discussions around shared public transport use of cabs? I think they're the next bits. I agree with the researchers that there are still some gaps there around disaggregating automation from electrification, and similarly with connectivity. But if for now, with the information that we have, you've got the AV, the automated vehicle safety law being developed, looking primarily at safety. You've got vehicle standards internationally being looked at and bringing in, and they're flexible as well, of course, and they're considering not just environmental factors, the international vehicle standards, but they're considering cybersecurity and data privacy as well in the development of those things. So you're right, though. Now is a good time that whilst those other concerns around safety and cyber and that are being looked at through vehicle standards, this is the time for us to come together to consider what how do we tackle the environmental bits, but you can't do them in isolation. They need to be part of a package of considering the social benefits, and that's how we integrate cabs into state government planning. And we've heard ministers at the state level talk about we can't just keep having more and more vehicles coming in, and automation runs the risk of having a lot more vehicles than we have now with nobody in them. So no answers right now, Miranda, but it's definitely it's been a great piece of work for us to.
Audio.
Oh,
No, it's back. Could be my end.
okay. So yeah, no answers yet, but we're, it's certainly a great piece of work for us to take forward.
Thank you.
Can I just make a
Raleigh or Megan, there. Yeah, I was just wondering if you had any perspectives on that.
Yeah. Sorry, jumping the gun. Yeah. Thanks, Miranda. Yeah, I think what the research made very clear was that, as Darren said, this is a very complex area, and that there can't be that planning in isolation for connection automated vehicles. We need to look at, shared mobility. We need to look at the people. We need to, work with the people already looking at active transport. We need to look at our environment portfolios. There's work going on in all of these spaces that is relevant to, the CAV outcomes that we're talking about here. So, a CAV team within a transport department can't be regulating for CAV in that way. There needs to be those links across portfolios, across departments, and also, collaborating with industries. A lot of the answers don't necessarily come from regulatory intervention. It could be, the way infrastructure is designed. So talking to those, private infrastructure providers, how do the highways work, that kind of thing. And I also just wanted to make the point as well, with the existing, regulatory work around automated vehicles, and that primarily focuses on safety, but, a number of the interventions there around safety, like, regulating the human users inside a vehicle and what they can and can't do. So that work's already ongoing, but we need to also look at some of those safety reforms with that sustainability lens, because some of those reforms actually do have an impact. So when you say someone inside a vehicle can't use their laptop, well, then now you're suddenly taking away, those, this bringing your lounge into the vehicle, you're taking that away. So then what does the impact mean for, the extent that these vehicles are used? So, a couple of points there, but obviously, that collaboration across portfolios is really important. And then that, that broader lens around some of the existing work is also important.
Thanks. Megan, did you have any thoughts? Lots around the old PT and raised speeds and so on from the state perspective.
Yeah, look, I'm less worried about phantom miles, I think, than probably others. I think that it doesn't behoove the market to have empty kilometers driven. And also the vehicles are very costly. And I don't see that coming down anytime soon for lots of reasons when you're embedding and trying to improve that technology. So I think that, to have empty kilometers driven is probably going to be less likely. And then at some point, ideally, road user charging and externalities then further encourage those positive behaviors. I think in terms of safety, one of the things when we look at this is I deal a lot with the advanced automated features now and rolling them out into vehicles. And a difference I'm noticing actually between how cab companies are approaching building their cars versus day-to-day manufacturers and what I'm seeing in the ANCAP rollout. And I'm seeing material differences roll through in terms of the efficiency and what they're trying to make versus, the advent, I think, of SUVs in the market. And so I think there are short-term things to, through our existing ANCAP and safety to encourage those positive behaviors as the market changes. And we're seeing some of that in the ANCAP 2026 and 2029 actually start to try and address these from that material level. I think in regards to public transportation, we definitely need a lot of work. Whilst we're doing really well on the electric vehicle front, the next part is how do we build this into public transport features that really encourage people that actually a superior product is the public transport cab future, because then we get a lot of space back. And I, for one, who don't own a car, but would love to see that sort of, future myself. So I think there's definitely opportunities there. And I think, it's expensive. And at some point, the cab companies need a return. And you can't do that with empty kilometers, travel. For someone like me, I get motion sick. The only thing I'm ever going to do in a car is sleep. Or I want to be driving it. So I will be happily, biking and doing all of those things into the future. And I think a lot of, my teenagers and their friends will be too. So I'm going to go positive, I guess, Miranda.
Thanks, Megan. Ada, I have a couple of questions for you in terms of, your role in a vehicle manufacturing sense. What do you think the likely emerging model would be that one would want to influence in a positive manner in terms of this social view? And the assumption that platooning is one of those base vehicle considerations in terms of its high benefit and potentially just assumed across all models, the likelihood of that emerging in earnest. Thoughts on that?
So I will start from answering the second question. So in the industry today, platooning, or semi-platooning in a way, it's kind of, in a way, available in the level 2 kind of features, like for things like adaptive cruise control, where the car from the previous car, it's kind of like on the highway, we can turn on the ACC to follow previous car, which is kind of platooning on the freeway. And we can definitely see benefits in terms of efficiency and reducing fatigue while driving on the freeway, or even on a normal road when the features of the functions of spec of the sensor become higher and higher to cover different speed ranges. So definitely there's a huge benefit in platooning. And when we move towards automation, one very important thing is to ensure the connectivity, as previously mentioned by the presentation, because at the moment, internationally in America, the automation is the car, like all the automated taxi, robot taxi, they are doing the self-driving by itself, and it doesn't really create a network benefit. Like we saw on the YouTube videos, like when they are trying to go back to the car park, if they don't coordinate with each other, they don't try to, when they are returning to a car park, they try to honk each other, and it just creates a lot of noise. Like it doesn't really solve the problem of like how do we safely harmonize everyone to go back to the car park together. And that's definitely a very important aspect to think about, because we understand CAF bring lots of safety benefit, lots of traffic efficiency benefit, and it works really well when it comes to a network effect. And regulation, of course, should become first, but it comes to a system, very complex to optimize it, to have the best productivity or best implementation. We need to have a holistic system of system thinking, design, architecture design, where we need to plan from the architecture of how do we implement the road infrastructure? How do we enable the road infrastructure connectivity, all the road operators connectivity with the road users, not just a car, not just passenger vehicle, not just robot taxi, but also public transport, scooters, motorbikes, cyclists, like everything to be combined together in terms of the system design to maximize all the benefits. So to have a social, providing the best social benefit, everything need to be work together, need to have a harmonized approach, harmonized protocols, and therefore it's currently quite missing. At the international scale, we are missing this kind of system architecture design. And Australia is a great place. We still have the opportunity because we have automated vehicle safety law framework coming up in 2027. And it's one of the most comprehensive legal framework, and based on that, we can put all the researchers, all the governments, all the Commonwealth, and all the industry together, and even the private road infrastructure provider together to come together to design this CAV or CA connected and automated mobility as a greater ecosystem.
Thanks, Ada. I might turn to some of the questions from the audience. In terms of a few we received prior to, perhaps Liam or Jago, apart from the impact on our transport system and the environmental outcomes, do we consider the impact on job markets and retraining? So I know also, Darren, you mentioned that in the introduction, the impacts on job markets and retraining in terms of perhaps the CAV strategy moving forward.
I'm happy to take that one. Conceivably, there could be an impact on labour markets through improved accessibility, reduced travel times, etc., for people commuting, or allowing people to live further away from their job for the same travel time. We didn't specifically look at the jobs dimension in itself, though it would have been covered through the expansion of the urban system, urban sprawl and so forth as an environmental impact. This project was looking specifically at the environmental impacts, not at, I guess, okay, distribution of jobs is an urban system question, but not specifically looking at the jobs themselves, just the fact that they might be dispersed.
Thanks.
Yeah. In terms of the workforce, yeah, absolutely. It's another piece of I think the social impact of CAVs that we're looking at quite closely as well. We're seeing, and a good example of where we're seeing this playing out to some degree is there's this tension between obviously driver shortages, which is an established factor internationally when it comes to heavy vehicles, and yet we've got the technology now through heavy vehicle automation that's allowing a lot of companies to look at the productivity benefits. We're seeing a whole bunch of states across the southern belt of the US looking at heavy vehicle automation to improve productivity of goods to market, but also to address driver shortage. But we're also seeing a social response, if you like, from employee groups that are concerned about the safety elements of these vehicles, these huge vehicles being on road without any safety driver or anyone on board, and the potential for risk for cities through that. So we are seeing some of those states that are allowing heavy vehicle automation to ensure that there are safety drivers on board to take back control of the vehicle at certain times. So I guess the point there is, even where there are job loss or job gaps, the automation does allow for, and hopefully can stimulate the creation of new jobs, better paid jobs that are safer. So it's a very interesting area that we're also quite interested in unpacking.
Thanks, Darren. We have another question from the audience here, maybe Ralia or Ada. It's around the sense of telecommunication requirements of a CAV. Is there a significant amount of telemetry data that needs to be transferred to enable things like platooning? And does this go through local networks or via the internet?
So in terms of
Ada.
Okay, so when it comes to the data size, like when it comes to communication protocol, telematics, it's about how we design the protocol. When we share in, for example, in the CIT's cooperative intelligent transport systems, we share everything pretty much a text format as a standard, where we just need to share coordinate of vehicle, heading of the vehicle, speed of vehicle. With all these basic very small amount of data sharing, we are able to compute how do we coordinate if, like in the day 3 of CITs, we should be able to coordinate between the vehicle, between the infrastructure. So in terms of data volume, it's not a huge need. It's about if we follow the best protocol, the right protocol in terms of design.
Thanks, Ada. We could probably fit in one more question, given we are at 1. For vehicle level environmental impacts, have you considered that there will be less crashes resulting in less movement of and storage, spare parts and manufacturing, reducing impacts on environment in moving parts around the world? Also have noted environmental impacts, reduce noise from AEVs compared with others. So it sounds like maybe Liam, yes.
No, we didn't. We didn't find those elements in the literature. So we didn't. So just to be very clear, we did a survey of the literature. We found everything that people had researched. We found elasticities and effects where we could, and then we applied them to a set of policy responses that governments could have, and then created the scenarios out of that. We limited the scope of the review to the environmental impacts, which means there are lots of questions like around labour market dynamics, social benefit, and safety. We took safety as a given. That we were told at the start, like, we're imagining we're at level 5 full automation. There is no driver required. There's probably not even a driver's ability to take over. It's like a lift. What are the environmental impacts? So we didn't look at those are the safety impacts. And it just didn't come up in the review, the environmental impacts of a decreased supply of parts. It's a good question. Like maybe that's on the list of things to look at, Darren.
Thanks, Liam. Given it's just past 1 now, I'd like to thank the speakers for your time today and the panel members for your input. It's been really interesting. And the interesting thing is, I feel like we're still talking about this, you know, a decade after we started modelling these more system-wide impacts or urban impacts. So, you know, the model is still emerging and it hasn't revealed its hand to us yet as policy owners. So hopefully we'll start to see more trends in other countries taking a stand in this space to help us guide through this process. I'd also like to thank the participants for your time. iMove will be posting this webinar within the next day or so, and the report is also available on iMove websites now. So thank you again for attending.